question is a great question because it forces you to understand the difference between what we're doing now and what we did in chapter 7. Chapter 7, we would take maybe x and compare it to 14, and then take, so I guess in chapter 7 we did this. We put x here and x there, and we put 14 here and 10 there. Anybody do that? Good. Why can't I not do that? Well, this is 8-1, so that hadn't gotten to that point yet. This is just Pythagorean theorem. Why does this only think about the theorem?
A squared plus b squared equals c squared.
That is true. Why does that not work?
Because this is not a altitude.
Okay. This is an altitude, but it's not a right triangle. That's not a right angle there, right? Okay. That's the reason this does not work. Okay. But these two smaller triangles are right triangles, correct? So can I say, now, with triangle questions, if you have multiple triangles, and you got to find a missing part, you want to start in the triangle that you know the most about. Okay, so of the two triangles, don't you know the most about this one? Okay. Would you say, now I don't know this distance here, I'm just going to call it A. Would you say that 4 squared plus A squared is equal to 4 radical 2 squared? Okay, so what's 4 squared? 16 plus A squared. Now we got to figure out how we do this, okay? This is the idea that we have, if you go back to Algebra 1, if you have A to the M, B to the N, raised to, let's just say R, you rewrite that as A to the MR, so you multiply that exponent with the R, and then B raised to the NR, you multiply that exponent N by that R. Does that make sense? Well, that's the rule, okay? Because, do you guys know why that's the rule? Probably not if it didn't make sense, right? What do I do? Let's just put like a 3 here. Let's use some specific values. If I had A squared, B to the third, and I raise that to the 4th power, does that mean I have A squared, B to the third, A squared, B to the third, A squared, B to the third, A squared, B to the third? Okay. And doesn't that mean that I have A squared times A squared times A squared times A squared times B cubed, B cubed, B cubed, B cubed? Okay. Now, the rule is, if I'm going to multiply like bases, what do you do with the exponents? Add them, right? So this is actually, these are all like bases, right? So is that A, 2 plus 2 plus 2 plus 2? And then B, 3 plus 3 plus 3 plus 3? Well, what's another way of repetitive addition? That'd be 4 times 2, right? That 4 times that 2. And this would be 4 times 3, right? That 4 times that 3. Okay? So that's why we're going to take that rule and say this would be A to the 8th, B to the 12th. That's a nice rule to have because you don't want to have to do all that stuff every time you see one of these problems. Okay? Or any problem that incorporates these exponent laws. The reason I talk about that is because we have that going on here. We have, actually, let me just do this to the side. We have 4 to the 1st power times radical 2, and I'll just raise that to the 1st power, squared. Well, then that becomes, multiply that 2 times that 1, it gives me 4 squared. And now I take this 2 times that 1, and now I get radical 2 squared, right? Does that make sense, everybody? So what's 4 squared? 16. What's radical 2 squared? 2. So I get A squared eventually. This is 32, right? Remove that 16 from both sides, so it gives me 16. So now A is 4. Does that make sense to everybody? Okay. So A is 4. Now, do you have information about the triangle on the right that allow you to solve for x? We can now say that 4 squared plus 10 squared is equal to x squared, right? It's giving me 116 is equal to x squared. What do I need to do then? Square root. And now 116 goes to what? 2 and 58. 58 goes to 2 and 29. And 29 is what kind of number? Okay, a number that doesn't have any perfect squares in it, right? Okay. Ultimately, even further than that, it's a number that doesn't have any divisors other than 1 in itself, so that's a prime number. Okay, those two can come out, and then the 29 stays underneath. So 2 radical 29 would be the length of x. Is that okay? Okay. You're going to see, especially as we move throughout the rest of the year, a lot of questions that stagger triangles onto one another. We're going to see several of them today, maybe, depending on how far we get. That's a very good question. Okay, so we've got what kind of triangle? Overall, what kind of triangle is this? That would be isosceles, right? Now, and hopefully you guys are seeing relationships of statements that I've told you in the past where when we say in chapter 4, hey, this is going to be a theorem that gets used a lot later on, and you understand maybe the importance of learning early on theorems because of how they impact later sections and later questions. When we cover something in chapter 4, you can't let it go away because in chapter 8, it becomes pretty vital. That's an isosceles triangle. And we had a corollary that said, in an isosceles triangle, if you take from the vertex angle, which is that angle up there, and you draw a line that is perpendicular to the bottom, what does it do to that bottom? Cut it in half, bisects it. Okay, so now if I want to find x, which is the length of that dotted line, which is it's an altitude. Okay, we can say x. Okay, this here would be 24, right? And this would be 30. Okay. Now when I go ahead and solve for x, I say x squared plus 24 squared is equal to 30 squared. What's 24 squared? Is it 576? Yep. Okay. 30 squared is 900. Okay. What is 900 minus 576? 324. And that is a perfect square. So my square root, what is the square root of 324? 18. So x is 18. I